or this is just a sketch. Okay, and then the shear is going up at 42. Somewhere around here. I might be a bit off. Okay, and I'm going to squeeze this here. Okay, so that is our Mohr circle. Okay, and then the next part of the question, we have done part A already. Okay, we've done B, we've done C. Next, we are going to do E, the principal plane orientation. Okay, so the principal plane orientation, okay, is basically it can be from point Y to the normal stress axis, and we are going to call this 2 theta P. Okay, or it can be from point X to the normal stress line, and this is also 2 theta P. Either one that you use, the answer will be the same. Okay. Now, before I go on, you guys will ask me, Eugene, why 2 theta P? Why not theta P? Why 2 theta P? Okay. I want you to watch this, okay? Let's look at the element. Okay. From point X to point Y surface, I will call this angle theta. Okay. And that angle theta is equal to 90 degrees. Okay. So this is on the element. On Mohr circle, right? Point X to point Y, right, is equal. So X angle from point X to point Y is equal to what? 180 degrees, right? So on the element, I'll write up here on the element, it is equal to theta, right? On Mohr circle is equal to 2 theta. Okay, I'm just going to explain to you this way, a quicker way. Or not, I'll spend 45 minutes writing 3 pages of equation, not 3, maybe, yeah, 3 pages of equation, and we come into the same thing. Okay, so important thing to take note, on the element is theta, on Mohr circle is 2 theta. Okay, so from here we are going to find 2 theta P. Right, again, very simple math. So tangent, so part D, tangent 2 theta P is equal to 30 divided by 30, 2 theta P. So 1, or tangent inverse 1 is equal to 45 degrees. Okay, and it is in a clockwise direction. Okay, why clockwise direction is from point Y, right? Point Y to here, right, is clockwise. It can be from point X, is also what? In a clockwise direction. So theta P is equal to 22.5 degrees, okay, clockwise. Okay. Right, now the next part can be so-called a very confusing part. Okay, now let's draw now, construct the element and its associated principal plane. Okay, so what I'll try to do is I will try to copy this circle. I'll come down here. I'll paste this. Let me see whether will this work. No. Okay. Oh. Hold on. Give me a second. No. Microsoft or the user. Let me try something else. It always do not work. It's okay. Let me see. Can I squeeze this now? Oh, it will work. Okay. Okay. So what we are trying to do down here is now construct the element at its principal plane. And I need this diagram nearby so that you can see what is going on. Okay. So this is part E of the question. Okay. So we just found out that the principal plane is 22.5 degrees in a clockwise rotation. Okay. So now we are going to construct axis. Okay, we are going to construct the axis. Okay, we're going to construct the axis now. The original axis. So this is your x-axis. And then this is your y-axis. Okay. So we're going to rotate 22.5 degrees in a clockwise direction. Okay, so I'm going to draw the principal plane axis now. I'm going to use a different color. I'm going to use orange. And it's going to be 22.5 degrees. So this is about 22.5 that I can get. Okay, so this is 22.5 degrees clockwise direction. Okay, I'm going to rotate this by 90 degrees. Okay, so this is our principal plane axis. And now I'm going to draw a square relative to the principal plane axis. Okay. Okay. Then on this plane now, okay, we know the angle of rotation, right? We know that this axis over here, the angle of rotation from here to here is 22.5 degrees clockwise. Okay. Then I will strongly recommend that we draw a horizontal line over here. And this horizontal line represents our y point. Oh, sorry. On Mohr circle. Okay. This horizontal line represent our y point, right? This vertical line that we've drawn is our x point on Mohr circle. Okay. So now watch this. From point X, right? From point X over here on our Mohr circle on point X, on point Y. Let's focus on point Y. On point Y over here, right? When we rotate by 45 degrees, you get this stress value over there, which is what? 32.426. Okay, 32.426 tensor. So on Mohr circle, you only rotate 22.5 degrees. And then this is our value. So this will be under tension. And it's going on at 32.426. 0.426 megapascal. Okay, and then if you look at point X, right, when you rotate by 45 degrees or 22.5 degrees, over here the value is minus 52.246. Right? So you're going, so from point X, you rotate 22.5 degrees. This will be going into compression, and it's going to be 52.246 megapascal. Okay. There will be no shear. Okay, there will be zero shear, and this is because the element is orientated at its principal plane. Okay, it's orientated at its principal plane. You have zero shearing stress. Okay, so what we have done down here, okay, is I've just taught you how to go from element, okay, element to Mohr circle, right, and then from Mohr circle, right, Mohr circle back to element. Okay, because element is the real world, right? Element is like strain gauges put on a structure. Mohr circle is a tool of analysis. Okay, so I feel that relating the two is important, or not. You say, Eugene, I just know Mohr circle. What does it actually mean in the real world? Okay, so you will know where the principal plane is orientated in the real world. Okay, later on I'll tell you how to use it, why this is critical. Is it critical every time, or is it critical sometimes? Okay, right. Anyone, any questions so far? Let me look at the chat. I don't see anything. Now I'm going to as usual make things worse. Okay, I'm going to you guys say, yeah, Eugene, thank you so much, you always make things worse. I'm going to now do something. Okay, I'm going to copy this the stress, this element down here. Okay, and I'm going to play this.
Eugene?
Yes.
Yeah, I have a dumb question.
No dumb question here. Yes.
All right. For the element, we always choose the square as an element so that we can apply the Mohr circle, right?
Now, the element is always square, you're right. But when we construct the element, like what I mentioned before, one surface is always big, right? The other two is the out of plane is usually the smaller surface area. Okay, that's always the case.
All right. Thank you.
Welcome. Right. So now we are going to look at the same element now. Okay, but I'm going to do something different. It's now I'm going to rotate the angle by 50 degrees. Okay, so we are going to look at the stress field at 50 degrees. Okay, at 50 degrees. Oh, not 50. I'll make it where's my oh I saw that wrongly. So let's do this at 30 degrees. Okay, let's do this at 30 degrees. Okay, so this line I've drawn is a 30 degrees line. Okay, so this is rotated from